close to. So there are various kinds of graphene derivatives. So we all know graphene, but then a lot of times we would like to reap the benefits of graphene derivatives, firstly because we would want to synthesize, produce them in a quantity that is comfortable enough for the purpose of first research and eventually for the purpose of production. So we have been producing graphene oxide in quantities that is comfortable enough for us to look into research areas such as water treatment and also desalination. And it has been used as a catalyst in our research for various chemical reactions. One of the applications that we really we always enjoy exploring will be the sensing platform. And we also use graphene oxide for the production of supercapacitors. And by modifying graphene oxide with various kinds of other compounds, metallic compounds, metal oxide, and also conducting polymers, each and every time you're almost sure that you're going to get something that is quite interesting. So the second type of graphene derivative that may interest you will be graphene nanoplatelets, widely used in production of advanced materials such as composites and also paints. I think it's considered advanced because it's got more than one functionalities, not just for the purpose of mechanical strength, but also to produce electrical and also thermal conductivity. And besides graphene, nanoplatelets, if employed in certain substrate, is able to provide some form of flexibility, and also widely used in batteries and also supercapacitors. And another one application that use a lot of graphene nanoplatelets will be the nanoelectronic devices. And the last derivative, but that's not least, is that it can be converted to graphene quantum dots from various kinds of reactants and easily convert solar energy into electricity. And therefore, you may see it in a lot of optoelectronics, can also be used in biosensors, medical imaging, and also drug delivery systems. And it also provides ultra-sensitive sensing ability. So the synthesis of graphene, as in graphene, I'm referring to pristine graphene. There are many different methods that's been reported and also employed in certain industries, certain market, and such as chemical vapor deposition, epitaxial growth on silicon carbide substrates, and also thermal chemical vapor deposition. So this cartoon here shows that the typical setup for a chemical vapor deposition reactor, where the gas undergoing several steps will then be converted into a continuous film of graphene. So another synthesis method that that any researcher who's interested to produce graphene in large quantity, in a quantity that is comfortable enough for the purpose of research, will be graphene oxide. So methods by Brody, Stoudemire, and also Hammers actually employ very concentrated acids and different kinds of concentrated acids as along with oxidants in order to produce graphene oxide. So the methods actually produce graphene oxide of different degree of oxidation. Nevertheless, you would definitely be able to get graphene oxide of a single layer. And it really depends on the amount of oxide functional groups that you want on the surface and on the edges of the graphene oxide. You are able to tune it accordingly. Next will be graphene nanoplatelets. Once again, this is one technique that you can get almost immediately graphene nanoplatelets, providing that you have precursors such as graphite. And these two methods that are very commonly employed will be ultrasonic and also liquid phase exfoliation. If you look at these two cartoons, the first cartoon show that you can actually tune the frequency in order to get graphene nanoplatelets of a certain lateral dimension as long as a certain thickness. So by providing the frequency, you'll be able to produce particles of water of different sizes. The smaller the particle, apparently, according to this research, is able to exfoliate graphene sheets gently and therefore able to provide larger dimension. Once again, if you're interested in this, I would suggest that you have You have to maybe discover the type of frequency that you would like for the type of graphene nanoplatelets that you're interested in. If you have a sonication probe, all you have to do is to introduce graphite powder into water and then sonicate it, and voila, almost immediately you'll be able to get your graphene nanoplatelets. But bear in mind that the graphene nanoplatelets that's produced in this case will be of very large distribution. Next will be the synthesis of graphene quantum dots, usually using chemical method of synthesis, such as hydrothermal, solution phase, and also photochemical. This is one typical straightforward example of producing graphene quantum dots, where you have the reactants introduce and subjected to thermal treatment, any kinds of thermal treatment of your choice, and then irradiate it under a certain wavelength, and you'll be able to get graphene quantum dots. So as mentioned earlier, graphene can be used in different kinds of industries. Even the categories of industries is able to provide a lot of ideas to many different kinds of application to one industry. So the ones that may interest the researchers in general, and also the industries in general, will be that of making membranes, composites, and also coatings, electronics, and also energy storage devices. So if you look at the graphene membrane, almost immediately the first industries that cross your mind would be that of the packaging industry, and then you will be able to look at the water research application. And next will be the composite, where probably you have seen some soles of the shoes may contain graphene. Probably it's not revealed. They just market it as able to increase the traction, able to provide some form of flexibility, and therefore enhance speed, that kind of way. And there are some parts of car and also aircrafts that require use of graphene as additive for these components. And lastly, for buildings such as additive for cement. So for electronics, there are researchers and also industries that are harvesting on the flexibility of graphene, and they can be employed in polymeric materials, fabric, substances to enhance certain properties such as thermal and also electrical conductivity. And finally, I would like to say that graphene is also widely used in I would say at this point, researched, okay, for energy storage devices. And therefore, you will probably, if you are interested in this field, you will see that there is a vast amount of prior arts that's related to graphene. So here, graphene as energy storage devices, you can actually utilize it for the components such as anode, cathode, and also separators, which I have been doing so in my research group. So this is just a generic depiction of the use of graphene in different kinds of components in an energy storage device. So just to give you an idea, in 2008, anode material is used in LIBs. So in this case, it's able to provide some form of safety. And same itself, probably much earlier than that, you'll be able to see graphene used as an active material for supercapacitors. And as you go on, you will see that graphene is actually used as an active material for cathode. And finally, the last bit here, which is on demand transformation. In recent years, you'll also be able to see graphene used as an active material for separators. So this on-demand transformation is the interesting thing for researchers, as we are given the opportunity and also the flexibility to exploit as much as we can in order to achieve a certain optimum measurements. So this is the reason why we do have extensive research when it comes to energy storage devices, because researchers and also industries, we are always striving to achieve the optimum specific capacitance optimum specific capacity, and also cycling stability. So if you look at this Ragon plot of energy density versus that of the power density, I think you will be able to see that there is these two distinctive devices that is kind of like monopolizing this plot, and which is batteries and also capacitors. So for batteries, naturally, it has got very high energy density, whereas for capacitors, it's got very high power density. So if you look at the green color areas, it's always new development of developing materials that are able to achieve high energy density and at the same time high power density, because a lot of times when we try to combine these two densities together, there's always some form of compromise that we have to take into consideration, and therefore this kind of new development is always very consistent. So the potential benefits of achieving that is that you'll be able to get getting high power density, high energy density, is that you will also be able to achieve long cycle life and also enhance safety. So I think this graph is interesting in the sense that it's able to give you some idea as the discharge time of some devices versus that of a system power rating. So as of now, battery is still leading. It is still able to provide you a better cycle life as opposed to supercapacitor, even though supercapacitor has got higher power. But then again, it really depends on what is it that you are looking for. And nevertheless, the pump, storage, hydro plant, and also CAES are also are still leading in this case. So the question is always, are we able to have a energy storage device that is able to meet all of these requirements within probably a short time of less than a decade? So if you look at the spider web graph here, in order to achieve graphene perfection, you will have to understand the method of synthesizing or preparing or producing graphene. So these are the 6 methods that are widely used by researchers, such as the reduction of graphene oxide, mechanical exfoliation, synthesis on silicon carbide, bottom-up synthesis, chemical vapor, and also liquid phase exfoliation. So if you look at each of these, the terms, the factors that influence the web, it will be the graphene quality, the cost aspect, and that is a low value corresponds to high cost production. All right, so this is something that is a drawback, which I believe that researchers and manufacturers are consistently trying to overcome: the scalability, the purity, and yield of the overall production process. So if you look at this, there's always pros and cons to a certain method. At the end of the day, the type of graphene that you would want to synthesize depends on the kind of applications. But then to say that again, there are so many kinds of applications, and therefore, if you want to cater to graphene to each of these applications, I think it is indeed research that is, it will be going on for a long time, continuous, until perfection is achieved. So what is the meaning of perfection? Are we any closer to perfection? It really depends on what is it that you are looking for. There are researchers making significant, leap and bounds improvement on the devices. Still a long way to go, because if you fabricate a device versus that of manufacturing it in so many number of cells of devices and then use it for the hybrid in the electric car application or what's not, there are things that you will have to compromise. Okay, but as of now, looking at the spider web graph, you know, right, that supercapacitor is able to achieve, okay, some of the factors that kind of like influence the perfection, such as safety, recyclability, environment, temperature range, charge acceptance, efficiency, cycle stability, power density, and also power cost. Don't mind me reading it because I just find that these factors are really interesting. Probably if you look at it one by one, and then if you look at the batteries within the web, you will find that somehow batteries are still lacking, okay, when compared to supercapacitor. But then again, I would have to say that in a nutshell, batteries do have a lot of advantages, and therefore the research that's related to batteries are still ongoing. So in conclusion, graphene has the potential to revolutionize energy storage. Cliche as it may sound, I strongly believe that someday graphene is going to change the market and is going to make its mark in the market. But then again, there's still a lot of research, and therefore, as researchers, I think we should always keep our passion going. Sometimes it's easier said than done. But then again, I think if you kind of like wane in terms of passion, probably you can check out the work of others in order to give you some ideas or the best method to move forward. So that is all from me. Thank you very much for your kind attention.
Thank you, Prof. Janet, for the impressive research talk. So now may I open the floor? May I open the question to the floor, please? Do we have any question from the participants? Anyone would like to ask anything? No? I do have one question for you, Prof. Janet, because I think that your research is really interesting, and I wonder what are the challenges that actually you face during the progress of your research?
The challenges?
Yes, yes.
There are so many, Dr. Ellie. Probably we talk about challenges in graphene. Yeah, in the synthesis of graphene. So it seems that there are so many methods of synthesizing graphene. And in order to select one method that really suits your application, I think you kind of like have to go through a lot of these methods first to really understand. So when you synthesize, you do not really know whether what you synthesize is something that you're looking for. So the next challenge will come to characterizing the material. So at the end of the day, I would say if you're really interested to start your work on graphene, probably take a look at probably understand yourself, your research area, look at the applications that you're interested to. Maybe you want to utilize graphene and then work backwards until you're able to get a graphene of your choice.
Okay, thank you, Prof. Janet. So actually, I do have another question, because it seems that you have actually performed extensive research for graphene. So do you have anything in your mind that what are the future direction of graphene material?
I think there's this graphene flagship, and also this Malaysia 𝗦𝗲𝗿𝗀 working on graphene, and there are so many different kinds of applications. If you want to scrutinize graphene in general in terms of applications, there is high-end application, and there is this middle end and also low end. By low end, I would say that it's not something that is easily achievable, but it may be achievable within the shorter period of time. So as if you to recall some of the information that I shared with you on the poster, is that one of the achievable, okay, application will be to use it as a composite. Okay, it's already out in the market, and indeed graphene is able to have proven to show traction on the sole of the shoes, able to provide professional runners some form of weightlessness when running. I think that's really important. So in terms of this, I think it's achieved. It's just that will you be able to see more of it in other countries and eventually in Malaysia? So there are also those that are quite difficult to achieve. The that requires higher end research, such as trying to harvest the electrical properties of graphene. Okay, so these require not just research, but also facilities. And therefore, I think a lot of stakeholders will need to be involved to make it happen.
Okay, thank you very much for the generous sharing. So again, we would like to congratulate you with the winning of the award, and we would like to thank you for the sharing of the session. And thank you, Prof. Janet. Thank you,
Dr. Ali. Thank you, everyone.
Thank you. So next, I'm going to introduce the next award winner, Dr. Nasir, who actually wins the Outstanding Young Chemist Award under the industry category. So Dr. Nasir, he obtained the Doctor of Philosophy degree in chemistry from IKM, and he currently works as the head of the research policy and planning branch, the research planning division in Forest Research Institute, Malaysia. Prior to that, he was the head of wood preservative analytical laboratory, biocomposite and wood protection program, Forest Product Division of FRIM from 2018 to 2021. So throughout his career, Dr. Nasir actually has 3 intellectual property disclosure, and he has won numerous innovation awards, up to 35 of them, let alone the international awards that he has received from the American Chemical Society in 2014. So apart from his commitment to FRIM, he also served the government of Malaysia in various task groups, including being a member of the working group on revision of ISO IEC 17025. Dr. Nasir is also actively engaged in the working group for several other entities related to wood preservative and forest research. So at present, his research focuses on the utilization of advanced technology in wood preservation, and he has published more than 116 scientific articles. So without further ado, may we invite Dr. Nasir to give your presentation, please?
Thank you, Dr. Ali. Can you hear me?
Yes, please.
Okay, Assalamualaikum dan salam sejahtera, salam hormat. Very good afternoon to all. Yang berbahagia, Datin Dr. 𝗦𝗽𝗲𝗿𝗀, Vice President of IKM, Yang Berusaha Associate Professor Dr. Juan, Honors Assistant Secretary of IKM, and also Chairman Malaysia Young Chemist Network. And then yang dihormati everyone who attended this webinar session. First of all, I would like to thank IKM for giving me the opportunity to present my showcase as the winner of the IKM Outstanding Young Chemist Award for the industry category.
Hi, Dr. Nasir, we can't hear you. I can't hear you. You have muted. Can you unmute yourself?
Okay.
Yes, yes.
Okay. I started active in research since 2003. At that time, I was involved in the development of sensors to detect the spiciness or hotness of chilies. If you can see from this slide, back in 2003, we already started developing the artificial intelligence for the detection of chili spiciness. Imagine that, since the last 20 years ago, the use of artificial intelligence is no longer as foreign as it used to be. So this is my first article. So accepted in the referred journal, and it is very nostalgic for me. So this is for my prelude. Okay. Okay, now we get into my field, which is a wood preservation and wood preservative. I will give a little explanation about the concept so that you all can better understand what I've been doing, since this field is relatively less popular.
Tak tahu apa dia cakap. Upah nanti pasal dengar. Okay?
Tak dengar ke suara saya? Suara saya jelas ke tak?
Yes, yes, I can
I can hear you. I can hear you. I can hear you.
Oh, okay.
Datin, please mute. Datin,
Okay.
Datin.
Okay.
Okay, I ingat. Okay.
Thank you.
Okay. Okay. So, slight introduction. Wood preservation refers to the practice of treating woods with chemicals or other materials. So this can involve various techniques such as pressure treatment, heat treatment, and also chemical treatment. So this animation is showing the simple process of wood treatment by pressure treatment, where the wood is put in the treatment vessels. Then we apply a vacuum to wood, usually in 30 minutes. So after that, the preservative liquid will be added until it fills the vessels. Then the pressure is applied, usually at 200 psi for 2 hours. And for the 2 hours, okay. Then after the pressure is applied, after that the liquid will flow back into the tank. And then we give a vacuum for 30 minutes. Then finally, the wood is removed again and dried until it reach the required moisture content. Okay. So wood preservative, on the other hand, is a substance or chemical that used in the wood preservative preservation process. So untreated wood is susceptible to decay and insect attack, which can significantly reduce its strength, durability, and lifespan. So basically, why do we treat wood? Because wood is treated to protect it from decay and insect attack, improve its durability and lifespan, and improve its aesthetics. So basically, my duties cover testing services and R&D. The focus of testing services is to provide testing services to customers, to the wood preservation industries and other stakeholders, including customers, students, and regulatory agencies. And why there are 4 focus of my R&D shown in the slide. Okay. So next, I will share a few highlights of my main achievement in the field of R&D, as I mentioned in the previous slide. So the first one is development of new method for chemical analysis. Okay. So my focus is on the development of chemical sensors and biosensors for determination of permethrin in treated wood. So why permethrin? So permethrin is a synthetic pyrethroid insecticide that is commonly used in wood preservation treatment. Incorporating permethrin into wood preservation can help to protect and prolong the lifespan of the wood. Okay. So the conventional method of detection of permethrin is using the HPLC and DC. Although this technique offer reliable result, they are non-portable device. Therefore, we need more alternative methods that are simple, easy in sensor design and of wide range application should be explored. So based on my study, I have developed 6 overall, the sensors, 1 chemical sensors, 2 enzyme biosensors, and 3 fungi biosensors, and also 1 DNA biosensors. Okay, so the second one, improvement of the treatment method. I also by myself constructing or develop a laboratory scale wood treatment plant. So this is because we want to minimize of the production of the waste after treatment, and also maintain the samples, the standard specification of the samples. And this one is ideal for testing for new preservative formulation. So in the referring to the Dr. Ngee talk, opening talk, so I open if anyone has interested in this research can come to FRIM and use this because the objective of I'm doing this is to help the other researchers to try their new preservative formulation. Okay, the third one is the testing of the commercial, the testing of the effectiveness of the commercial preservative. So the first one is collaboration, the dual treatment collaborations with the Tongsing Wood Industries in Berhad to test the durability of wood treated with the dual treatment method. So here is the couple wood that was struck by lightning, and it has a very poor properties. But after we apply this technique, the dual treatment, we successfully extend its life, and until now the wood is still okay. Okay. The second one also I want to share that we also doing the durability of mangrove wood treated by copper chrome arsenic CCA, and you can see that the mangrove is less durable wood, and when we treated with the CCA, it's prolonged the lifespan until now. So this is until now about the 18 years studies, and we still collecting the data. Okay, the final one, the final part of my R&D is development of new method, new wood preservative formulation. So this one is I collaborate with the Professor Dr. 𝗦𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲 of characterization of Diastoria hispida, ubi gadung, and convert it to wood coating, and the coating show the total inhibitory to white throat fungus, and the coating has the potential to be used as a novel organic preservative. So the second one, this one is collaboration work with Associate Professors CHM Dr. 𝗦𝗲𝗲𝗲𝗲𝗲𝗲𝗲 from the School of Chemical Sciences, Institute of Science, Malaysia. So we incorporate the chlorotoluene into proteolytic acid, copolyethylene glycol nanoparticle for rubber preservation. It shows that nanoparticles have provide excellent resistance against termite and fungi in the rubber. So this one is the recent work by us in the just published in 2023. Also collaboration with the Associate Professor Dr. 𝗦𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲𝗲, and we incorporate the permeating into chitosan polymeric nanoparticle using nanoprecipitation method. And for the rubber wood preservation, it shows that the nanoparticle permeating chitosan nanoparticle has a high resistance against subterranean termite. So I'm going to my other side of my job description. 15 years of providing testing services in the field of wood preservative and wood preservation. Why 15 years? Because in 2020 I was appointed to be head of research policy and planning branch, and my lab is taken by Dr. Tumira, the research. So we can see that wood preservation, we offer services for industry to treat their wood. And also we conducted the analytical testing for wood preservative. So without a strong team, I think the effort for testing is not my effort alone. It is require a strong teamwork, and I'm grateful to be in strong team led by Dr. Salama and work closely with a great chemist like Dr. 𝗦𝗲𝗶𝗲𝗲. And the number of samples since 2005 to 2020 is 4,300, while the number of customers is about 300. So the type of the test carried out is divided into two. In organic wood preservative samples and organic wood preservative samples. So we roughly generate income for FRIM is about 350,000. And so how we can contribute indirectly to country? The testing services provided by Wood Preservative Analytical Level 3 FRIM indirectly contribute the income generated by the country's timber industry. You can see the outcome. This one is fishbone diagram. So we just little contribution, just little contribution, but still have a contribution to the billion, to the downstream industry value as a fraction of the country GDP since 2016 to 2019. Okay. Here is the research opportunity in wood preservation and wood preservative. So there's a large opportunity to development of sustainable wood preservative with the increasing focus on the sustainability. Associate Professor Juan also mentioned about the SDG and the environmental protection. There is need to develop wood preservative that are eco-friendly. And the second one, need to do evaluation of the effectiveness of the existing wood preservative also. So this is the opportunity, research opportunity in the wood preservation. Okay. And I also want to share my advice for young chemists. I'm a conservative person, and I'm very hardworking, really hardworking. But I strongly emphasize that work-life balance is very important nowadays. Because I think when we work and we don't have a life work balance, it will affect to our health. So the second one is I want to emphasize to find a good mentor. So not focus in the same institution, but go out. And lastly, I think the networking is very important. And don't work in silo. Get out. If you can build the networking even abroad, that's better. And I want to take this opportunity to special thanks to my mentor and also my collaborator, yang bahagia Prof. Datuk Musa, Prof. Lee Yok Heng, Prof. Dr. Lee, Prof. Azwan, and my colleagues in FRIM. And also acknowledgement for for Dr. Ismail Hadi Padan, the Director General of FRIM, because nominated me for this award, and also Dr. Ling Swee Kong, also chemist, that seconded my nomination, and also collaborators from IKM, from Unimax, and Tong Sing Wood Industry, Archwoods, Sergio, and also from Mosti Mohe Mafi for the grant, and also American Chemical Society, and also IKM for sponsored me for the Bitcoin travel grant. With that, I end my presentation. Thank you.
Thank you, Dr. Nasir. It's really something that we do not usually encounter because we are, I mean, at least I myself, I'm from the academic stream.
Yeah,
It's
yeah.
really interesting.
So
Yeah.
I try to present this different perspectives.
Yes, indeed.
Yeah.
So perhaps do we have any question from the floor? Participants, do we have any question? If we don't mind, perhaps let me ask one question first. I do have something that I would like to know more. So in the chemicals that you use for the wood preservation, do we actually get some negative impact from the use, like, you know, when we use chemical in the long term, we are getting the negative impact?
Oh yes, I think this other studies that we need to conduct, especially in the safety for the humans and health. So there is potential that the wood preservative that we use now is have a negative impact. There's a special session to discuss that in the every year in the we call that International Research Group on Wood Preservative, RG. So the opportunity I can see from that is to synthesize or to make new formulations that have less impact to human health.
Thank you for the insight. So it seems that actually we do encounter a lot of wood species.
Yeah.
So when we encounter different types of wood species, do we use different types of the preservation methods for the research?
Yeah. Because the time given to me is about 15 minutes. I actually in the introduction I should put we call that the hazard class. We call that hazard class for the use to show the use of wood preservation. Hazard class 1 to hazard class 6. So hazard class 1 is less toxic, and then hazard class 1 and 2 is less toxic. Hazard class 3, 4 middle toxic, and hazard class 5, 6 is more toxic. So 1, 2 hazard class is normally you use for the internal wooding and have a contact with human. Hazard class 3 to 6 normally you treated wood for the external use. And this also we need to consider the species of the wood, and the Malaysian have a grading system for the durable, non-durable, less durable. So the most durable one maybe no need to treat, like cengau, the expensive wood, merbau. But the less durable wood, such as rubber wood, so we need to treat. And also the type of the chemical preservative that we should use also different. Bergantung kepada dia punya penggunaan.
Okay, so it seems that you must have acquired a lot of knowledge about the wood types.
Yeah.
Able to perform the research, right?
Yeah, if anyone here is interested in this field, come to FRIM, and I can give 2 or 3 hour lectures, so maybe can help you to understand more.
Yeah, sure. Maybe we can have some arrangement. So I think I would like to thank you first for your presentation today. And yeah, thank you again and congratulate for the winning of the award.
Okay.
And so next, may I invite Professor Pang, the chairman of the Outstanding Young Chemist Award, to give a short speech to conclude the session for today. Professor. Yeah. Hi, Prof. Pang.
I'm here.
Okay.
Can you hear me?
Now we can hear you. Yes.
Can you hear me?
Yes, we can hear you.
Oh, okay. So today I just want to show my acknowledgement to all the participants and also Datin Jyoti and also Dr. John and also Dr. Ellie for helping to become the MC and the organizing committee, and also all my friends and also the students who are supporting us for joining this outstanding young chemist online webinar. So besides, I also want to show high acknowledgement to my outstanding young chemist award, the organizing committee lah, which Dr. Yvonne, she's not here, and Dr. Neil, Mr. Ivan, and Dr. Tan Yi Sing, and also a lot of like Dr. Ellie and also Jordan, who are always helping us for the outstanding young chemist network. Okay, so Dr. Ellie, can we snap a photo before we end our talk today?
Yes, please. So I would like, I will need the IKM staff to help to check the photos of all the participants.
Dr. Ellie, can you help us to snap? You just print screen. You just print screen.
Sure. Print screen. Okay, sure.
Can,
Okay. So let me.
Can everyone on your camera, and then after that we take a photo together. Prof. Janet, Dr. Nasir. Okay, congratulations. So can we take a group photo? Dr. Ellie, everyone is on the webcam, right?
Not yet. Most of them they have. Yeah. Which on the camera? Most of them they have not yet. Perhaps to just capture one first. 1, 2, 3. Okay, maybe I'll have another one. 1, 2, 3. Okay, so I've taken the photo. Yes. Give me a minute. Okay, so with that, yeah, sure. Okay, so with that, I would like to thank you all for attending the session and also congratulate the winners again, Professor Janet and Dr. Nasir. And with that, we would like to thank you for attending the session, and that's the end of the session today. Wishing you a very great afternoon for today. Thank you.
Thank you, Dr. Ali, for your time. Thank you.
Juan, kalau ada apa saya boleh tolong, bagi tahu for IKM.
Congratulations, bro.
So kalau
Prof. Janet.
Thank you. Have a nice evening. Bye.
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 Thank you, Datin. Datin. Okay. Bye.
okay.